Okay, everybody, this is going to be the acid rain PowerPoint presentation. So I know you're probably sick of acid rain, but we're going to do several activities with it. We're going to do several sections of notes with it. All of this will be useful when we get to your test. So definitely save all these activities somewhere where you can access them when we start reviewing. So this is not the image that you're going to see on your activity yet, but acid rain formation, we're going to go through and talk about it a little bit. So first of all, what is acid rain? We've talked about this. It results when either sulfur dioxide or nitrogen oxides dissolve in water and they create those acids. We've talked about sulfuric acid, sulfurous acid, nitric acid, nitrous acid. Those are strong acids. Our natural rain is acidic, just a little bit, because it has a weak acid called carbonic acid, but those ones are going to make strong acids. The previous picture summarizes the entire process of acid rain production. You've got over here, you have your sulfur dioxides and nitrogen oxides rising up from these buildings, and then they get carried with the clouds over and they fall as rain somewhere else. But we're going to talk about that in more detail, okay? The explanation following the picture describes the chemistry behind the process. So this again is another one of these where it just sort of summarizes, but we're going to go through in more detail now. So if you look over here on the left, we've got buildings and volcanoes and cars creating different things. So sulfur dioxide coming from both the factory type places and volcanoes. Nitrogen oxides are coming, hopefully you can tell that's coming from the car. Okay, that could also be a little bit of that in like factories, but anything with a really high temperature section to it is going to have the ability to combine nitrogen and oxygen and make those nitrogen oxides. Lightning is another place where you can find nitrogen oxides. Those go up into the air and they create sulfur and nitrogen compounds that sit in the clouds because those things are gases and they mix with those clouds. And the clouds react with them to create the acids. Now, this picture doesn't really show the acids being created, okay, but the sulfur compounds will make those sulfuric acids, the nitrogen compounds with those nitric acids, and we're going to have 3 different types of deposition, which means depositing those acids onto the surface of the planet. Wet deposition on the far right there, that is rain or snow. Both of those are wet deposition, technically, okay? That's when the acid has combined with water. There's a droplet or a snowflake that has a little bit of the acid in it, and those deposit on the ground. Dry deposition is when you have an acid molecule that has been created, but it's not inside a water droplet. It just dry deposits on the ground. They come straight out of the air into the soil or dirt or dust and just gets onto the ground that way. That's dry deposition. Okay, I'm not going to ask you a ton of questions about these, but this just shows you how those molecules are going to actually interact and form those acids. Okay, so you've got sulfurous acid up at the top. You've got sulfur dioxides combining in multiple ways to make sulfur trioxide, which mixes with water to make sulfuric acid. And down at the bottom again, sulfuric acid being produced in a slightly different way with dust helping that process. So lots of different ways that these acids can be produced. Now we're going to look at these maps. Now this is 1999, and we're looking at pH of the soils and the rains that happen. So actually this would be rain pH, okay? The dark orange areas are under 4.3 in pH. So this isn't the colors that we would see in universal indicator. This map is just color coded based on pH. Normal rain is going to be those dark green areas. So if you look at where we live in Wyoming, we're in that dark green, maybe just a slight shade lighter green area where we live here in Laramie. So we have fairly normal rain, slightly more acidic than that 6 pH, okay? But if you look in the central United States, you know, the high industry area, Ohio, Pennsylvania, Illinois, that area, lots and lots of orange. This is where our industrial revolution started. We're going to have a lot more factories in that area, which means a lot more pollution being created, those sulfur dioxides, nitric oxides that will then go on to mix with and form the acid rain. Okay, here are this bottom right picture I really like because this statue was not created to look like that. His face is being eaten away and his jacket are being eaten away by sulfur dioxide and nitrogen oxide acid rains. So sulfuric and nitric acid rains. So marble statues, limestone is going to react and dissolve, and we're going to get some calcium oxide and carbon dioxide as it's eaten away. Okay, smokestacks are a big source of sulfur dioxide in the atmosphere. Again, factories, a natural source would be those volcanoes, but we are getting a lot of that sulfur dioxide from burning fossil fuels because that sulfur was trapped before and now we're releasing it into the air when we burn those fuels. Okay, nitric acid. Nitric acid, to focus a little bit more on that, it stains proteins yellow like your skin. It's used, we use it in industry to make explosives, fertilizers, rubbers, plastics, dyes, pharmaceuticals. So some drugs, we need nitric acid to help us produce those drugs. And now we're going to go through a nitrate ion concentration. So if we look back at this one is hydrogen ion. This could be any acid, right? Any acid is going to have hydrogen. Now we're going to look at nitrates. So this map is 1985. And what I'm going to do is I'm going to start speeding through the years and you're going to see how the color shifts and changes on the country's map. And I might stop in a few places, but this is 1985. And again, we're looking at that place that's really high in industry, right around those Great Lakes, Ohio, Pennsylvania, New York, Western New York. And we're looking at Illinois. We're looking at Indiana. Those places have more orange, which is more nitrate in the soil, and that's deposited from nitric acid in our acid rain. Okay, so let's watch how this changes over the years. So 1986, 87, 88, 89, 90. Now we're seeing an orange spot develop in Utah, so we got some industry developing there. 91, 92, 93, 94, 95, 96, 97, 98, 99, 2000, 2001, 2002, 2003, 2004. Oh, so now we switch types of maps, okay? As you notice, as it gets oranger and then less orange as we go, part of that is regulations. When we create laws that reduce the amount of pollution, we're going to get less acid rain. Okay, we're going to switch map types now. Again, nitrate levels, the redder the area, the higher the nitrate. So they just switched their, the NADP switched how they made their maps in 2005. So this is 2005, 2007, so we jumped a little bit. So we had major improvement in that gap. 2009, again, the more we know about this stuff, the more we want to control it and not let it into our atmosphere. 2011, a little bit higher in that Arizona, North Texas, panhandle of the Oklahoma area. So we might have found some oil wells there. We might have started some oil refineries. I'm not sure. We'd have to look into those areas to figure that out. Looks really good in 2014. So that's where we're ending with our data there, okay? Okay, sulfuric acid. Sulfuric acid is the most commonly produced acid industrial chemical in the world, okay? And it's used in petroleum refining, and that's why it's the most common, because we want to refine petroleum to get energy, to get gasoline, gasoline, diesel, other things that we get from petroleum, oil, okay? Metallurgy, manufacture of fertilizers, and lots of industrial processes you can see there. And now we're going to do the same thing. We're going to go through the maps for sulfate. So 85, 86, 87, 88, 89, 90, 91, 92. So this is suggesting we're getting more regulations because the amount of sulfate is shrinking. 93, 94, 95, 96, 97, 98, 99, 2000, 1, 2, 3, and then we switch map types again. So again, 2003, this is looking really good. We might have created regulations. We might have also created a better way to refine things so that we don't let that sulfate escape. We might be capturing it somehow. okay? 2005. Now, the units are different, so it's not like we just changed dramatically. But if you notice on this map, the 2.5 is like an orange, and the 2 is a yellow. On this map, the 2.5 is red. So they just changed what color things were to make that distinction. So 2.5. So this is still better than we were in 2001, for example. 2007, 2009, excellent. 11. So again, that North Texas area, we're getting some more sulfates. So I'm guessing sometime around 2010 or so, there was a refinery opened there, and that increased the sulfate productions. 2013, 2014, I imagine that's the last one. So looking really good. We've improved our acid rain situation. Here in 1944, you can see on the left, that statue looked great. That's how it was made. And then in the present, you can see what acid rain has done to it. I mean, it doesn't even really look human really anymore. All right, now let's look at this. So potential problem areas because of sensitive soils are in green. Areas that are problems because of air pollution can lead to acid deposition, that's yellow. And then current problem areas, including lakes and rivers, are in red. So that's one interesting thing to look at. Another really interesting piece about this is that while a lot of these acid rains are created in maybe the Ohio area of the country, they don't necessarily stay there, okay? They're created, they go up into the air, the clouds can carry them over into those yellow areas like the central United States, and they can deposit them there. So that's why it's emissions leading to acid deposition in those yellow areas, is because the airflow, air currents are going to carry that pollution to another place. So remember, we're all in it together. It is important that we protect our planet. There are lots of different approaches to that, and every approach, every effort is going to be well intended. Okay, so that is that's all for this activity with acid rain. Go ahead and fill out the questions. Please rewatch as you need, and reach out with email if you need any help on that, or come see me. Talk to you later. Have a good weekend.